Hello, in this video I will describe the printing steps of flexible material or soft material. In this video I will use NinjaFlex, which is a soft filament. The diameter of this filament is 1.75 millimeter. This is the model that I used practically. I can show you here the printing guidelines. You can see here that the nozzle temperature is ranged from 225 to 250, and it's higher than the rigid material. In the previous videos we used the PLA filament, and from the printing characteristic you can see that the maximum temperature you can use with the rigid material is 220, but here in the flexible material you will need a higher temperature. And the infill speed is ranged from 15 to 35 millimeter. This is 35 the maximum infill speed. The speed of printing flexible or soft material is less than rigid material. In rigid material like APS or PLA, the infill speed can reach to 70 or 80 millimeter per second. But here you need a low speed in order to print soft material like NinjaFlex. This is the software. Ender-3 can be used to print a rigid and soft material. So we will import our model. Here is the model. I want to print this with the soft material. I will choose here as we mentioned before, you can choose the type of 3D printer or the name. Here you can choose the material. I will choose the TPU. And as we said before, that the nozzle side is fixed. You cannot change this nozzle side. It is fixed or standard for Ender-3 Swan Pro. Then here the printing setting. We can adjust the printing setting from the website. Temperature is from 225 to 250. The parameters I will enter here from my practical experiments, as I already used this material before. My application needs infill density 50%. And regarding the temperature, I see that the perfect temperature for my model is 2025, and the bed temperature is 60. I think it's good for the model for printing flexible material like NinjaFlex. Maybe some of you will ask why I put a temperature for the bed, for this bed, in order to keep the model fixed or attached to the bed itself. If you make the temperature of the bed equal to 0, the model may run away from the bed or escape from the bed, so the printing will fail. So we put this 60, and you can make sure from this. I don't think so that there is any data related to the bed temperature, but for NinjaFlex I think 60 is perfect. Printing speed. From the data sheet they say that the printing speed from 15 to 35 millimeter per second. So the maximum is 35. I used 35 before in the practical models, but the 3D printer failed to print this model. And I see that the perfect infill speed for NinjaFlex 6 or 5 millimeter per second, not within this range. If you choose this range, sometimes the 3D printer can or successful to print your model, or sometimes no. But with a low speed, it will perfectly create the model. So I choose this 6, and the travel speed, and this is as we said before, that this is the speed of the 3D printer while not there is no material in space, or the free motion of the 3D printer. Actually, this 100 millimeter per second, and I see that this is the perfect print setting for my model. Slice to generate the G code. As you can see here, that this model will take 6 hours. The expected time to print this model is 6 hours 28 minutes, and this long time, as we choose the printing speed very low. You can increase this speed to, for example, 35, and you can see here that it will take only 1 hour. But with a high speed, with high printing speed, the 3D printer will fail to print this model. So I see that 6 or 5 is the perfect printing speed of NinjaFlex material. It will take a long time, but it will generate a successful model. As you can see that I don't need to add any support, and the dimension of the model is 1440 x, y, and z. This is the height of the model. Using flexible material to print this model, sometimes the 3D printer fails to print this part due to the height itself. So sometimes I need to rotate the model and rotate like this. And in order to bring this, the 3D printer will fail to bring this model, so I need to add a support with this specs. As you can see here in the preview, here is the model. The software add the support, and here is my model. In next video I will show you the practical models while this model is vertical without any support, and with support. Thank you very much.